All right, folks. Hello and welcome to another edition of Algebra Interpretations with your host, me. We are going to be talking about some graph transformations, specifically with regard to square root functions, but in order to address what that means, we're going to need to talk about graph transformations in general first. So I'm going to flip over to a blank screen here for a second so we can talk about graph transformations. And if you know all this, great, you can just skip ahead, but I really want to talk about graph transformations in general. So when we talk about y equals some function, this is what's known as the parent function. And in the case of today's sheet, we're going to be doing this with square root exclusively. But this could be done with x squared, it could be done with cube root, it could be done with 1 over x, it could be done with e to the x. There's a billion things we could use as a parent function. And these graph transformations are going to apply to all of them. Basically, we're going to take this parent function, whatever it is, and we're going to start jabbing numbers into it. So we're going to say, well, what happens if we take our function, whatever it might be? What if we multiplied it by something on the outside? So now it's like 3 square root of x. Or what if we multiplied it by something on the inside, which would be like square root of 3x? Or what happens if we added or subtracted a number, like square root of x minus 3? Or what if we randomly added a number on the outside, square root of x plus 3, like that. So these are all examples of what I mean by A, B, C, and D, and they all represent different things that will happen to the graph. As a slight caveat here, I do need to put parentheses around the x minus c. I don't think you're going to see anything related to the letter B on this upcoming sheet. I didn't look at it ahead of time, so I could be proven wrong about that. But the difference between A and B with a lot of functions is not very obvious, so I'm not going to linger on B too heavily. What I am going to do, however, is talk about what each of these things does to the graph. So we're going to think about this. We're going to look at these letters. We're going to say, okay, so A, B, C, and D. So A is a multiply on the outside. And the multiplying does a stretching of the graph. And because it is on the outside of the function, it is after you apply whatever this process is, square root or x squared or whatever. So it's going to affect the output, which is to say it's going to affect y. So it's going to stretch in the vertical direction. B, on the other hand, is a multiply on the inside. So it's still going to do a stretch, but it's going to be before we apply the process of f of x. So it's going to be done to the input, which is to say it's going to stretch it horizontally. C is an add, or I wrote it as a subtract, but treat it as an add on the inside. Now, because it's on the inside, again, it's affecting the input, so it's a horizontal thing, but instead of being an add, it's a shift. It's going to slide the graph to the right or to the left. And D is an add on the outside. You can probably guess based on what we had previously in this table here, because it's an add, it's going to be a shift. And because it's on the outside, it's going to be shifted vertically. So this is your cheat sheet for transformations right here. And if you can follow along with that, it'll start to make things a little more clear. I do have a few extra bonus tidbits. So extra notes. First of all, B functions backwards from how we expect it to. Again, I don't think we're going to have to deal with B right now, but I do want to throw in that B actually goes backwards if the B value, if it's like square root of 2x, it doesn't stretch 2 times, it actually compresses by a factor of 2, which means it only gets half as wide. C also functions backwards. which is why we write it as minus c instead of plus c. That way you don't have to think about it. You just go, oh, it's supposed to be a minus on the inside here. But I can address another way to deal with this, which is to say that you're going to start at the point that would make the inside equal to 0. So if you get confused, if you're like, is it to the left or to the right? I don't know. Well, if it says x minus 3 in here, if it was like square root of x minus 3, we go, oh, well, x equals 3 makes this 0. So therefore, we're going to start at x equals 3. So when we do our sliding, we're not going to start at -3, we're going to start at +3. So that's another way of looking at it. Additionally, if a or b are negative, then they don't just stretch, they also flip. So a negative a is a vertical flip, and a negative b is a horizontal flip. And I will be happy to show what those things look like if we should need them. All right, now I am going to have to erase the screen from here, so you might want to jot down any of these things that you need in order to be able to refer back to them, because unfortunately I am going to change tabs, and when I change tabs, this happens. So considering that's pretty freaking ugly, we're going to have to erase my writing. Sad story. There it goes. Okay, so let's look at this first question. Describe the transformation. We're not actually doing the transformation yet. We're just describing it. Okay, so let's remember it's A times f of b x minus c plus d. And as a side note, some teachers use h and k here instead of c and d. If you're using h and k, I apologize. I'm going to stick to my c and d notation though. So this is the square root of x. Now we notice that we have minus in here, and that's not minus. So I'm going to raise x minus -4 and then plus 3. So what I'm going to see from this is that c is equal to -4 and d is equal to 3. All right, what do we do with that? Well, that means that we are going to shift horizontally by -4. Shift horizontally by -4. What does that mean? That means we go to the left by 4. And d is +3, so it means we're going to shift vertically by 3. Okay, a positive number in the y direction would be up, so we're going to shift up by 3. And so our whole answer for this is it's going to be, we're going to take square root of x as our parent function, and we're going to shift it left by 4 and up by 3. And that's it. Let's go to number 2. Same idea, except now it's already minus. So I'm going to say c is just straight up equal to 1. D is equal to, think of this as plus -8. So d is equal to -8. So now we're going to write this up. We're going to say we're going to shift, not scuffed, shift. All right, we're going to go 1 in the horizontal direction. Horizontal positive direction would be to the right by 1. And shifting, we're going to go -8 in the vertical direction. Negative vertical would be down, so down by 8. And there we have it. All right, so that was easy enough, I hope, but now we're going to make it more complicated, because we're going to see that we have -3 here, that's c equals 3. We have +5, that's d equals 5, but now we've got this lead number, that's the a. A equals -2. All right, so what does that mean? Well, let's start with c and d. We're going to shift right by 3. We're going to shift down, or excuse me, up by 5, because c and d are both positive. But then we need to think about, what does a do? A is a vertical stretch, so we will have a vertical stretch by a factor of times 2. Why 2? Because this is a 2. It's a -2, but it's a 2. All right, but what about the fact that it's negative? Well, remember my extra notes at the end, I tacked on that if it's negative, it's a flip. So there's also going to be a vertical flip, which your teacher might also write as a reflection across the x-axis if they want to be fancy. But really, it's a vertical flip. You turn it upside down. So that's my answer for 3. How do we do 4? Well, same sort of deal. Our C isn't there, it's 0, right? It's C equals 0 if you really want to write that. We don't. D is plus -9, so -9 here. And then A, the multiply outside is -1. We're saying times negative to make this negative out here. Okay, so with C being 0, we don't have a shift left or right, so we're not going to write that part. With D being a -9, we do have a vertical, so we're going to shift either up or down. Let's think negative is going to go in the down direction by 9. And then, all right, our vertical stretch is by a factor of 1. You don't need to write this. I'm going to write it just to make it clear what I'm talking about. But the more important thing about that A not being trivial is that we have a vertical flip because it's negative. So again, I'm going to tell you, don't worry about this right here. This is completely irrelevant, but the shift down by 9 and the vertical flip are what we're going to deal with. All right, number 5. So we've got a lead number out front, that's the A. We've got, I'm going to treat this as x minus -5 because we need our number inside to be subtracted to make this work correctly. So C equals -5. And there's no number on the end here, so D doesn't exist, or it's just 0 if you prefer. All right, so let's interpret. C is a shift. It's by 5, but which way? So it's a horizontal shift, and it's in the negative direction. Horizontal negative is to the left. And then we've got a vertical stretch by a factor of times 3. Everything will be 3 times as tall as it would have otherwise been. And for number 6, we've got a lead negative. A is equal to -1. No number here, just a negative, so we treat it like -1 times. C is equal to 8, and D is equal to 1. Again, because this is a minus, then that's what we want. It is a positive 8. Okay, so we will shift. C equals 8. That should be a right by 8. D is shift up by 1. And A is a vertical flip. So this is all the stuff that's going to happen with these questions. Now, that's us just talking out loud about what's going to happen without actually doing it. We haven't actually graphed any of these. So what we're seeing here is just a summary of how do we get these things. But now we need to actually put it into play. So we're going to scroll down here and go, oh my God, there's graphs. Oh my God, there's more graphs. So let's talk about these graphs. What do we need to know? Well, first of all, graph the following square root functions. So let's interpret this. Obviously, we've got to answer the domain and range here. But underneath that, we have no A value. We do, however, have a C value. C is equal to, we're going to treat this as minus -1. So C is equal to -1. And D is the number that's added on the outside. It is plus -2. So that means that when we go to graph these, we are going to shift left by 1. We're going to shift down by 2. So that is what's going to happen to this graph. Now, I'm going to draw in a different color what a normal square root looks like. The square root of 0 is 0, square root of 1 is 1, the square root of 4 is 2. And we would connect it and we would do something like this. And that's our basic old square root of x. That's our parent graph that I referred to before. Now we're going to draw this, but we're going to move everything to the left by 1 and down by 2. So this point right here at 0, 0 is going to go left 1, down by 2. This point is left 1, down by 2. Left 1, down by 2. and then we draw the same figure. I'm going to do this again. I'm going to give you a different interpretation if you like this better. We're going to take the original point and go left one down by 2, but then we're going to pretend this is our new origin. When it comes to graphing, and we're going to say this is like 0, 0, and this is the 1, 1, and 2, 3, 4. This is 4, 2. And I think that that's a more effective way of understanding what's actually happening. I like to do it that way. So I will just say, here's our new origin, and then draw it from there. And that takes care of all of our shifting like that. Now, the domain and the range. Domain by default of our parent function is from 0 to infinity with a hard bracket on 0 because we can do square root of 0, right? All the x values from here over are in play. And the range is everything from 0 up. So in that regard, the range is also 0 to infinity by default. However, we have messed with it. We have moved things around. So you can see very clearly that our domain is not starting from 0. In this case, our domain is starting from an x value of -1. So we're going to subtract 1 from 0 and from infinity, which doesn't do anything to infinity. We're going to say this goes from -1 to infinity. Or if your teacher prefers this notation, x is greater than or equal to -1. I'm going to keep using set notation, but that is equivalent to this. All right, and then the range, similarly, we moved everything down by 2, so -2, -2. Our range is going to be -2 to infinity. And the easiest way to determine the range is just to look at the graph. You can see very clearly it goes from here up. So obviously it's everything from -2 and above. All right, so now let's move on to number 2 and let's interpret negative x minus 2 minus 3. Okay, so we're going to say that we've got an a of -1, we've got a c of 2, and we've got a d of -3. So let's interpret that just like we did up top. We're going to say that c is a shift to the right by 2. D is a shift down by 3. And then the a being negative means we have a vertical flip. All right, so what the bleep does that mean? Well, once again, I'm going to draw the parent function. I don't recommend drawing the parent function every single time unless you need to. But if you do need to, go right ahead and do it. So the parent function looks like this at 0, 0, at 1, 1, and at 4, 2, because those are the numbers we can easily take the square root of that are small. Obviously, the next point we would draw would be 9, 3, because 9 is the next number we can square root and still get a whole number answer. All right, so we need to shift to the right by 2 and down by 3. So I'm going to do that first. I'm going to do this in 2 steps just to show you what's going to happen. So we have right by 2, 1, 2, and down by 3. So this is our new starting point, if you will. And so I'm going to have a point there, and then I'm going to have my 1, 1, and then 2, 3, 4, 2. And so this is what it would look like if we shifted to the right by 2 and down by 3. And you're saying, but wait a second, we also flipped it vertically. And I'd say, oh, you're correct, we did. So what we're going to do is we're going to say, well, compared to this line right here, which is what we're comparing everything against, we're going to flip it over. And we're going to say, no, it's actually down here. Now, you could do it in the other order. You could do the flip first, and you could say, let me flip it here, here, and here, and then let me move it after that. And that would work as well. And so maybe your teacher explained it in that order, but I like to say from where we are, instead of going up, we're going down. And so we would have gone up. No, lol, we're going down instead. And so this green version that I've drawn here, that is your actual answer that you're going to work from. All right, domain. Well, we can see we've got everything from here over. That is x equals 2 because we have a c value of 2. So it's going to go from 2 to infinity. Now the range is a little different because it's from here down. So we're going to have to write this a little differently. We don't go up to infinity, but we do go down to negative infinity. So starting from negative infinity, the place where we stop is at -3. And we do include -3, so that's a hard bracket, whereas this is a parentheses. Infinity is always parentheses. All right, so there's number 2 down. Let's talk about number 3. And by 3, I mean 9. Obviously, add 6 to the numbers I just said a second ago. All right, so we're going to look at this and we're going to say, well, we've got a 4 multiplied in front. That means A equals 4. We got a -3 on the inside. That's C equals 3. We got a +2 in back. That's D equals 2. So we're going to do a shift. Not what I just put on the screen there a second ago. We are absolutely not going to do that. You might want to take one of those on this particular homework assignment, but we're not going to be doing that. We're going to shift right by 3. We're going to have a vertical shift down by, or not down. D is positive. Shift up by 2. I was just seeing if you were paying attention. You were supposed to go, wait a second. All right, but then we got A. Now, A is not negative. There's no vertical flip, but there is the other component, which is we have a vertical stretch by a factor of 4. All right, so what the heck does that look like? Well, base version 001142. Okay, that's good and fine. I'm not going to connect them because I want you to get used to not having to connect them, not having to draw the whole thing. But we're going to shift right by 3 and up by 2. So from here, I'm going to go right by 3 and up by 2. 1, 2, 3, 1, 2. So this is going to be my starting point, if you will. And then the next point would go here. And then the next point would go here. I don't want to be doing this in green. Hold on. Because I want to address the flip or the stretch factor as well. 1, 2, 3. So next one would be actually off the end here. So we would have this, except we've got this stretch by a factor of 4. So what does that do? Well, it makes everything get 4 times as tall. So remember, I'm calling this my origin, if you will. So we're going to get 4 times as tall as 0. That's still 0. So this point stays right where it is. But this point is 1 off the line, this horizontal line that we're working from, our new axis, if you will. Instead of getting 1 off the line, we're now going to get 4 off the line, because it is times 4. And this point that's 2 off the line would then become like 8 off the line, which obviously isn't in the picture. So what does our graph look like? It looks like this. Your teacher probably doesn't want to see it coming out of the page there like that, but it's basically going to be, let me get rid of all this extra garbage. It's going to look like that. And so the key points that you will need to have here is you will need to have this point right here, 3, 2. And then the next point would be 1 to the right. And if you want, you could just plug in a 4 and say, what does that give me? 4 minus 3 is 1, times 4 is 4, plus 2 is 6. Or you can recognize that it would have been +1 normally, but oh wait, it's +1 times 4 because we stretched it vertically by a factor of 4. You'll remember on that other sheet I talked about the B and how that would do a stretch on the x-axis or on the x number. And so obviously we don't have that, but if we did, it would be the same deal. The other thing I mentioned was if you're getting confused about the negative on the C, and I said, oh, well, just think of it as what makes this equal to 0. What makes x minus 3 equal to 0? 3 does. So therefore, we're going to start at x equals 3. And we're going to start at a y value of 2. So effectively, this is going to be where we kind of start things off, here and here. That's where we're going to draw from. I also said on this previous question over here, if you wanted to, you could do the stretch first. You could say instead of 0, 1, 4, 2, I'm going to do 0 and then up. I should use a different color. That's really hard to read. I could make it 4 times as tall. So instead of 1, we go to 4. And then instead of 2, we go to 8. And then we go over and up and over and up and over and up. So you can do it that way as well. I feel like that's a lot more tedious to do. And so that's why I don't normally do it that way myself. But If you're looking for a very concrete, very straightforward way, yes, you can do that. So if that's a more natural way, then do it that way. Okay, we didn't answer domain and range here. Hopefully you can recognize this is 3 upward and 2 upward. So no big deal here. All right, we're going to do one more here. Number 10. A equals -2. There is no C. C is 0. D is equal to 4. All right, so what are we going to have to reckon with here? Well, we've got no shift horizontally, but we do have a vertical shift up by 4. Now, what about the A equals -2? So the fact that it's -2 means we got two things going on. First of all, the 2 part means we have stretched by a factor of 2. The negative means we have a vertical flip. All right, so let's break this apart, shall we? So we're going to shift everything up by 4. So we're going to start from this spot right here. This is like our 0, 0 and our 1, 1 and our 4, 2. But we need to move these. We're going to go, instead of up, we're going to go down, and we're going to go down twice as far. So this point stays right where it is, but this one, instead of going up by 1, it's going to go down by 2 to right there. This point, instead of going up by 2, it's going to go down by 4. The next one would have gone up, instead of up by 3, it would have gone down by 6. So it's going to end up looking like this. And so this is basically our graph right here. No, put that back. Thank you. And so our domain is everything above 0, because we didn't do anything weird with that. And our range is everything below 4. All right, so there is the rundown of what's going on this top part of the sheet here. Now, if you scroll down, you'll notice we've got all these additional questions. Oh, but now they're using the cube root. So what's different about this? Well, the cube root, unlike the square root, if we talk about y equals square root of x, we go to 0, 0, we go to 1, 1, we go to 4, 2, because those are the numbers we know how to square root. If we kept going, and very frequently I see sheets of these that go 10 in each direction rather than just like 5. So we go to 9, 3. If we really wanted to keep going, we could go to 16, 4, and 25, 5, and 36, 6, and basically just keep squaring numbers and then put the square in the first slot. And so it looks like this. The reason we don't put anything over here is because you can't do the square root of a negative. Well, actually, that's not completely true. It would be imaginary, but we don't graph imaginary numbers, at least not on a standard axis like we're doing here. So it just hard cuts off. However, once we start doing the cube root, all bets are off, because -1 to the third power is -1. So that means the cube root of -1 is -1. We can have negatives. So we need to think about, okay, what can we cube root? Well, we can cube root 0. It's 0, 0. We can cube root 1. 1 to the third power is 1, so the cube root of 1 is 1. The next number that we get a cube of, 2 cubed is 8. So the cube root of 8 is 2. Whoops, I wrote that backwards. And then it goes the same thing in reverse over here. -1, -1. And we also get -8, -2. And so these are the key points if you're drawing a more complete graph. And it looks like you do a square root over here, and then it looks like you kind of do a reverse upside down twisty square root over here. Or if you prefer, it looks like x cubed turns on its side, if you're familiar with the x cubed graph. Just like this is kind of sort of the x squared graph, but only half of it because we have to pass the vertical line test to make it a function. All right, so this is going to be our model for how we're going to create a cube root graph. Once again, all the rules I talked about before apply. All that parent function business, we're just using a different parent function. But the over by C and the up by D and the stretching out by A and the vertical flip, all that stuff still applies exactly the way it would have before. Nothing has changed other than we're throwing a tail on in the other direction, and it's a little more stretched out. So let's come back over to our tab here. And we're going to ask ourselves, how does this go? Well, and I notice they don't ask about domain and range for this one, which is nice because the domain and range for both of these is all real numbers. No matter what happens, domain and range, it just goes to infinity and to negative infinity in both directions. But let's break this apart. So we've got a C value of 2. We've got a D value of 1. Again, H and K if your teacher prefers H and K. So that means we're going to shift right by 2. We're going to shift down by 1. Now, because this is not going to look like much more than just a switched around square root graph, I'm going to keep going beyond the extent of the graph just to emphasize, but it would be by parent 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. 8, 2 would be there. Negative 1 would be there, and then 2, 3, 4, 5, 6, 7, 8 would be like there. So our parent function looks like this. So there we have it. That's our parent function. Now, let's do the shifting. So we're going to go right by 2 and down by 1. So our origin here is going to go right by 2, down by 1, and then we're going to recreate the same graph from this position. So either you take all the points and you slide them right 2 and down 1, or you say this is 0, 0, so this becomes the new 1, 1. The new 2, 8 is like way out here, so we don't care. The new negative 1 is over here, and the new negative 8, negative 2 is going to just barely fit onto the graph, so I'm going to throw that on here. And then we do our best to create the graph as smoothly as we can make it look, and there is our graph. Oops. So the green version there, that is our graph. Moving on to 12. A is negative 1. C is also negative 1. It's x minus negative 1. And D is equal to 3. That's a horrible D. D equals 3. Okay. So let's interpret. We have shift to the left by 1. We have shift up by 3. And we have a vertical flip. All right, so I'm going to just go ahead and create the graph, and I'm going to let you try to figure out why this happens the way it does. So left up by 3, okay. And then we would go to 1, 1, which would be here, but we're flipping it, so we're going to go here. 2, 3, 4, 5, 6, 7, 8. There's our next point, and then here's negative 1, and the next one would be way off the end. Okay. So I'm going to argue that this is the answer right here. Something like that. Now, are you able to spot why that played out? So we started here. These were like our starting points, right? We're going to take this left and up by 3. Left and up by 3, left and up by 3. However, compared to this being our like starting line, as it were, we have to flip everything across. So this now becomes up here and this goes down here. Again, if you don't like doing it in that order, let's back up. I just erased my text, but oh well. If you prefer, we can do the vertical flipping first. We can say instead of going from here, 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 we're now going to be here, here, and here. And then we're going to move left 1 and up 3, which puts us to here, here, and here. So if you like that better than my new origin tactic, then do it that way. All right. 13 is much easier, thankfully. That is just a shift right by 3 and down by 4. So I'm going to leave that as an exercise to the reader. And 14 is going to be an A value of -2 and a D value of -1. All right. So let's figure out what the bleep we're doing here. We've got shift vertically down by 1. We've got a stretch vertically by a factor of 2. And we've got a vertical flip. All right, so I'll use the policy I used on the last one, which is to say that our parent function was here. We're going to do a flip and a stretch by a factor of 2. We'll do that first this time. So this flips to 0. +1 flips to -2. -1 flips to +2. And then, oh wait, everything has to be down by 2. So we have actually here, and actually here, and actually here. And then it's going to be something like this. And the reason I drew it like that, I know that my next point is going to be 2 away and off the end. And this is going to be 2 away and off the end as well. So that's why I drew it specifically like that. But there's my graph. All right. So hopefully that answers, or at least gives an idea of how to address each of these questions. Now let's look at the bottom. What is the domain and range for all cube root functions? I actually answered that before. All real numbers for both. Because you can plug in an infinity and have it not mess anything up. You can plug in a negative infinity and have it not mess up, and you will get positive infinity and negative infinity respectively. All right, so now 16, when you look at the ocean, the distance you can see to the horizon can be modeled by blah, where A is your altitude. Determine at what altitude you can see 10 miles. All right, so I could do a whole bunch of thing about interpreting this graph, but I don't think that's really necessary. I think what we just want to do is go, all right, so D is distance, and A is altitude. We want to know the altitude when you can see 10 miles. That's D. So 10 equals 1.22 square root of A, and let's solve for A. All right, we're going to have to grab a calculator for this one, obviously. So we'll divide by 1.22, and we will get that 8.197 is the square root of A. Now, to get A by itself, what do we have to do? We have to undo a square root. How do you undo a square root? You square both sides. So let's square that number. Rather than retyping into the calculator, I'm literally just going to hit answer squared so that I don't get any rounding error. And I get A equals 67.186. Now, because this is a real world question, we need to make sure we have units, and we probably should write a sentence. So the altitude at which you can see 10 miles is 67.186 feet. And if you want to throw above sea level in there, you can. But the number one most important rule of all test taking, and I'm going to extend this to this homework question, these word problems. Rule 1, which I'm going to write in nice big font here. Rule 1 is always answer the question. Whatever is being asked, you give them that. You make sure that whatever they want, you have it, and you circle, you box it, you do whatever it takes to say, here's the answer, I gave it to you, I did it. The worst thing in the world is to do everything correctly and then still not get full credit. All right, to find the radius r of a sphere of volume V, use the equation blah. Oh, that's the backwards version of V equals 4/3 pi r cubed. They decide to take that and solve it for r for some reason. This is the normal volume formula, by the way. All right, It has a volume of 225 feet. What is the radius of the balloon? All right, I'll take my thing away because we need to use their version. So we know that V equals 225, and we want to go, what is R? All right, well, this is straightforward enough. R is equal to the cube root of 3 times V divided by 4 pi. And I mean, the way that's written, you could just straight up put it into the calculator. I would be very careful about doing that all in one giant bite, though, because it's very easy to screw things up on the calculator. If you do the stuff within the cube root, the number you should get is 53.714. And if you did not, it's probably because you did this. And the problem with this is this says divided by 4 times pi. And order of operations implicitly puts a times in here, meaning divide by 4 and then multiply the result by 3.14. So if you're going to do that, make sure you do divided by parentheses 4 pi. Very easy mistake to make when you're working with these calculators. And because you're working with a calculator and these answers are very abstract, you don't know any better when the answer is complete garbage. All right, and this is 3.773. So I'm then going to write a sentence just to emphasize the radius of the balloon is 3.773 feet. I wouldn't want to do it if I was handwriting because pencil, but typing, it's no big deal to me. All right, write an equation for the function whose graph is shown. All right, so the first question we have to ask is what kind of graph is it? We've dealt with square root and cube root graphs. So is this a square root or a cube root graph? Well, if it was a cube root, there'd be extra stuff down here, wouldn't there? But it's not here. So it's not a cube root. So therefore, this is a square root. So what I'm going to say then is that our parent function is the square root of x. Or as I like to refer to it, squirt of x. That's programmer speak. Okay. But it's not a regular old square root function, is it? They messed with it. What did they do? Well, they took it and they moved it over and they moved it down. By how much? Looks like we went 2 this way and we went 3 down. So what does that tell us? We have a vertical shift left by 2, and we have, a horizontal shift. I'll get my horizontal and vertical straight here. And we have a vertical shift down by 3. Now think back to how we set these up before. We were going in the other direction. What did we have to do to have a shift left by 2? We needed a C value of -2. And to shift down by 3, we needed a D value of -3. So square root of x minus c plus d, and I'm leaving off the a because there is no a. We're just going to say, oh, by the way, this number right here is -2, and this number is -3. So y equals the square root of x minus -2, which we'll write as a +2, and then plus -3 or -3. And there we go, we're done. Hopefully that addresses everything that you would need to see for questions of this type. I know that I did some of this a little quickly. I feel like I could have explained some of this in greater detail, but honestly, we're already going on quite a lengthy video as it is. So if you have any questions, feel free to ask me. Otherwise, good luck, and I'll see you in the next one.